In this lecture, let's explore about the boot sequence of BBB. There are different boot sequences are possible, and you can alter the boot sequence. To alter the boot sequence, there is a boot button on the board, and the boot button is S2. If you don't press the boot button and if you just give the power to the board, then this boot sequence will be followed. That means the hardware will first try to boot from the onboard eMMC, that is embedded MMC. So if it doesn't find any valid partition, then it would check the next boot source, that is the SD card. If it doesn't find any valid boot images over there, then it would go to UART 0 and then it would try to boot from USB 0. That's the default boot sequence if you don't press the boot button. As I said already, the board already comes with pre-installed Debian OS on the eMMC. That's the reason whenever you give power to the board boots from the eMMC. You need not to press anything. Just give the power to the board, it boots. But in our case, we don't want to boot from the eMMC. Remember that. We want to boot from SD card. That's why we have to follow this boot sequence. You have to press the boot button during power up. Whenever you give power to the board, the boot button must be pressed. In that case, the first boot source becomes SPI, which would be invalid in our case. That's why the board tries to boot from MMC 0, which is nothing but micro SD slot. We have to keep valid partition and valid boot images on the SD card so that the board can boot from the micro SD card. In our case, this would be the boot sequence. But you need not to keep pressing the boot button S2 again and again during power up. There is one hack which I will cover in later lectures, that we can make our board boots from the micro SD card whenever we give power to the board. That we'll explore later. Actually, the boot button S2 affects a register called sysboot. Sysboot is actually a register, or it is a bit field of a control register of the SoC. A pressing or not pressing of S2 button actually affects the contents of the sysboot. That's what makes the board to select between different boot sequences. Here is a S2 button. This is a boot button. Just check your board. Near the micro SD card slot, you see one button. That is boot button named as S2. And you also see two more buttons. One is power button and another one is reset button. Let's understand what are the use case of this power button, reset button and boot button. Let's first understand what exactly is the use case of power button. By press and holding this button for 10 to 20 seconds, you can power down the board. Once the board is powered, if you want to power it down, then you need not to remove the USB cable which is connected to the computer. You can just do a long press on this power button, about 10 to 20 seconds. So the board will go into the power down mode. Once you power down the board, gently press this button one time again. Your board will again power up. The use case is, instead of removing and connecting power sources to your board again and again, you can use this button to power down and power up. That's the use case. Next one is reset button. Pressing this button resets the board. But note that the boot sequence is not affected by the reset action. Why? Because the reset action will not affect the sysboot bits. You see a sysboot bits here. This is not affected by the reset. That's the reason the boot sequence will remain same. After that, boot button. You can use this button to change the boot sequence during power up of the board. In this course, I don't think we'll be using a power button more frequently. We may use it 1 or 2 times, not more than that. Most of the time, we'll be just resetting the board. We'll not be using boot button more frequently as well. For some initial setup, we'll be using boot button and power button. And after that, you need not to use that button. I will guide you how to use these buttons, no problem. Let's move forward. So in summary, our board has got two important interfaces. The SoC can boot from the embedded MMC, which is of 4 gigabytes, or our SoC can boot from external interface such as micro SD card connector. The micro SD card connector is called as MMC0 interface, and the onboard eMMC is called as MMC1 interface. As I said before, we will not be booting from MMC1 interface. We'll be booting from the MMC0 interface, that is the micro SD card. In the next lecture, I will cover booting from micro SD card interface, and I will see you in the next lecture.